So good morning everybody. I am going to take the counter design with state diagram. Okay. So this under this topic is we have to design how the counter design by using state diagram is designed. Okay. So let us see this diagram. There are how many states are here? 0, 1, 3, 4, 5, 7. These are the states which represents the state. Okay. That is what the state diagram. Okay. So for example, if you want to consider this 0, what is the previous state of 0? 7. What is the next state of 0? 1. If you want to consider the state as 1, what is the previous state of 1? What is the previous state of 1? 0. What is the previous state of 1? What is the next state of 1? 3. Similarly, if you consider the subsequent state, the previous state is the before value and next state is what? The after value. Okay. So counter design using state diagram. This is what the table indicates. Okay. So for example, if you consider the 3 bits, right? So 3 bits start from 0 to 7. Okay. 0, 0, 0. What is the next state? 0, 0, 0, 1. Okay. If it is the current state is 0, 0, 1, what is the next state? 0, 1, 0. If the current state is 0, 1, 0, what is the next state? 0, 1, 1. Okay. If the current state is 0, 1, 1, what is the next state? 1, 0, 0. If the current state is 1, 0, 0, the next state is what? 1, 0, 1. This is nothing but 0, it starts from 0, 1, 2, 3, 4, 5, 6, 7. Okay. From the 0, all the 3 bits are 0. If it is 1, the first 2 bit is 0 and the last bit is 1. If it is 2, the first and last bit is 0, the center bit is 2. Okay. If it is 3, the last 2 bits is 1. Okay. If it is 4, the first bit is 1 and the next 2 bits are 0. If it is 5, the first and last bit is 1, the middle bit is 0. If it is 6, 1, 1, 0. If it is 7, 1, 1, 1. Okay. It will continue up to this cycle. Okay. So counter design, it has a 3 flip-flops represent 3 bits. Okay. Q1, Q2 and Q0. Initially the counter start from the state 0, 0, 0. Okay. So within this state, each pulse, the counter increments by 1. Okay. The counter increments by 1. Okay. Sorry. Initially the counter start from 0, 0, 0. With each clock pulse, the counter increments by 1. The following binary sequence from 0, 0 to 1, 1, 1 and then back to 0, 0, 0. The counter resets to 0, 0 after reaching the maximum count to 1, 1, 1. Each transition is the state diagram represents the flip-flop changing its states based on the clock inputs. Okay. So it represents 3 cycles is Q2, Q1, Q0. Okay. You can implement this counter using J-Clay flip-flops or D flip-flops, ensuring that the flip-flop inputs are approximately connected based on the state transitions defined in the state diagram. Okay. So additionally, you need to provide the clock signal to trigger the state transitions. Okay. So first one, let us see what is the step 1. There are 8 steps are here to define the counter design using the state diagram. So define 1. So clearly define the requirements of the counter. So for example, if it is a 2-bit counter, the maximum state is 4. If it is a 3-bit counter, the maximum state is 8. Okay. Similarly, this clearly defines the requirements for the counter, including the number of bits and counting sequence. Next, number 2. Calculate the number of states required based on counting sequence and the number of bits. For example, if it is n number of bits, we have 2 power n output bits. Okay. So for example, if it is a 2n bits, 2 power 2 is what? 4 output bits. Okay. If it is a 3n bits, if n is equal to 3, 2 power 3 is what? 8 bits. Okay. So next step 3 and step 4. Create the state diagram. So create a state diagram that represents the sequential behavior of the counter. Each state represents a unique combination of the counter output bits and the transition between the states representing the counting sequence. Assign binary value to each state in the state diagram and ensure that each state has a unique binary coding. Okay. In step 3 and step 4, create a state diagram and step 4, assign state encodings. Okay. And step 5 and step 6, define inputs and outputs. Identify any inputs and outputs required for the counter. Okay. Step 6, define the conditions under which counter transition from one state to another. This typically involves specifying the next state for the current state based on the clock input and any other control signals. At last, there are two states. Implement state transition. Based on the state diagram and state transition condition, implementing the logic for transitioning between the states using the flip-flops, combination logic, or any necessary control signals. At last, verify design. Simulate the counter design using the digital design tool and hardware description language to verify its behaves as it expected. Ensure that counter counts correctly all the states and transition according to this state diagram. So okay, this is what the state diagram, counter design using state diagram. Okay, there are 8 steps. First, we need to define the requirements. Number 2, define the number of states. Number 3, create a state diagram. Number 3, assign state encodings. Number 5, define inputs and outputs. Number 6, determine state transitions. Number 7, implement state transitions. At last, verify the design. So thank you all.